So today we're going to talk about light and electrons, and specifically electromagnetic radiation. So first off, what is light? That is what we see as color and brightness, and it's actually an electromagnetic radiation. It's partly electric, partly magnetic, and it flows in a straight line, or it radiates. So where does light even come from? Well, we get our light from suns and stars, but how do they even make light? Well, it all starts with the atoms. The nucleus is surrounded by electrons that orbit. Like planets in the solar system, electrons stay in the same orbit unless electrons get kicked into a different orbit. So here's an analogy. What happens when you drink energy drinks, have a lot of sugar? You have a sugar rush. You are full of energy. But once you use up that energy, you crash. Well, when electrons use up their energy and crash, they're moving around in different orbitals. Well, when they do that, they let go of all this energy, and that's what we see as light. So each electron that jumps back emits a photon of light. That color depends on how much energy it has, and that's how you get different colors. Now, if they jump in at all the different ranges, at all the different colors, that's when you get white, which is a mixture of all colors. So here you can see a picture that shows the combination of the three primary colors make white. So light is a particle. A photon is like a particle, but it has no mass. So think of a photon as a grain of sand. We see so many photons at the same time. It's like seeing sand on the beach. It almost looks like a solid piece of ground until you're close up. When light hits film in a film camera, it acts like photons. But sometimes light also acts like a wave. A wave has a wavelength, a speed, and a frequency. So if you think about the beach, the faster the waves are, the more frequent you see them come on shore. The color depends on the frequency, and the wavelength gets shorter as the frequency goes up. So speed of light travels at about 300 trillion meters per second. So it takes about 8 minutes for a light wave to travel from the sun to the earth. So if the sun was to explode, we actually wouldn't know about it for 8 minutes because we wouldn't be able to see it. When we see the moon, it reflects the sun's light, and it takes 1 second for light to be reflected off the moon. So like if the moon exploded, it would just take 1 second for us to see it, because that's how long it takes for that light to travel. Light and matter. So when light hits something like air, glass, a green wall, black dress, it may be transmitted, reflected, or absorbed. Most of the time, it is a combination of all three. Here is kind of a visual of showing how it can pass through, how it can be reflected, how it can even be scattered where it reflects in different angles, how it can be absorbed or refracted. So if you put a pencil in a cup of water, you can see that it doesn't even look like the pencil in the water and out of the water even are connected because of the way it refracts. So absorption, if something absorbs all colors, it is black. So it's like the opposite of how we see it in the light. So astronomers use light to study the stars. They collect energy from stars from a telescope. Each atom has a special pattern of light frequencies like a fingerprint. The fingerprint of frequencies will be shifted if the star is moving away or if it's moving toward us. Kind of like when you pass a train, the way the sound changes as you pass it. The temperature of the star can be determined from the color of the star. So here are two pictures of a ring nebula. One is visible light and one is infrared light. So the visible light and the infrared light. So using both visible and infrared, you can actually gather different information about what's going on. So now we're going to briefly go over electromagnetic waves and the electromagnetic spectrum. So you need to know electromagnetic waves are transverse waves without a medium, or basically it travels through empty space. So vibrations in electrical and magnetic field is how they travel. So it's different waves, both horizontal and vertical. They have some magnetic and some electrical properties to them, which is why they're called electromagnetic radiation or waves. When an electric field changes, so does the magnetic field, and when the magnetic field changes, so does the electric field. So when one vibrates, so does the other. They're related to each other. And the result of that is an electromagnetic wave. Electromagnetic waves travel at the speed of light because light is a form of electromagnetic waves. So basically, they can go around the world 8 times in 1 second. That's how fast the speed of light is. So, is light or electromagnetic radiation waves or particles? Well, actually, it's a little bit of both. It has properties of both. You need to know electromagnetic spectrum is a name for the range of the electromagnetic waves when placed in order of increasing frequency. So the different types, you have radio waves, which is where the waves are farthest apart, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. So with this information, I want you to fill in the chart that is on the next page in your digital notebook. I've got to pull it up right here. So using this slide, you will need to fill in and answer the electromagnetic wave and what is where. And you'll notice the only part of this that you can see is just this section right here, the visible light section. Everything else is not visible to our eyes because our eyes can't perceive it, but they are still there. If you have any questions about electromagnetic spectrum, if you take chemistry 2, we actually go into each of these in huge detail and talk about the different types and what you can do and what's dangerous and what's not. But for Chem 1, we're just going to go over the basics and how this is related to electrons and radiation. If you have any questions, let me know.